Up next, Team House Rules.
Could you tell us a little bit of how you came about to join this challenge and why you decided to compete?
Yeah, sure. Thanks. So 2 years ago, myself and my teammate Cyrus, we both competed in the first challenge. It was a fire swarm hackathon, also put on by some of the same organization, and it was a lot of fun. We competed online, and then we took a trip out to Dayton, Ohio, and competed in person, and wrote code together, and had a chance to kind of solve some problems and use some of our kind of nerdy engineering skills, which is a hobby for both of us, and we had a lot of fun. Then this year, we received an email from the creators of the last challenge saying that they were reintroducing the challenge. They're trying to make it into a yearly competition, and they were looking for some more teams to join. And I forwarded off to my friend, and he said that he'd be down for giving it another try. So we jumped in. This time being an online version, so it worked well. Since both of us, I was living in Germany at the time, he was living in Bahrain at the time. So we just collaborated in our off time, and then were able to submit some code. So it worked out pretty well.
So if we take a look at the video, you can look at your strategy and how, when you coded it, you might not have realized it would perform this way. And so how do you think it evolved, and how might have you attacked the problem differently now that you've seen some of the interaction with the environment and, for example, the other team?
So our code for this one was structured based on the kind of rules of the environment that we're given. Looking at the other team, it in some ways reinforces, I think, how we attacked the problem, which was the simplest solution is going to be the best solution for this type of a problem set, where the two teams don't interact that much. You're almost better to kind of ignore some of those aspects of the game and to keep your drones focused on their mission, which is finding the other flag and getting back. And if you start bogging it down with too much extra tasks or missions for your drones, you're going to run into issues where they're not max performing what the main mission is, which is to find the flag and to get it back. So our code is very simple. It's very hard-coded and logical, and not as dynamic as it needs to be, because the problem is pretty straightforward, if that makes sense.
Yeah, so autonomous systems, especially multi-agent systems, are a very challenging problem. So how did you decompose it into multiple pieces? Because you said you sort of broke it into a structured approach where you might have prioritized some things over other things. Yeah,
so the first step was running the simulation enough times that we understood all of the kind of the nuances of the environment, in terms of kind of speeds of the drones, the radiuses that they can scan, the pluses and minuses to optimize the different drone types. Through experimentation and kind of debugging, you come to realize that, for instance, your jammer drone, which is, you would think like, okay, that's your jammer drone, you want him to go jam the other team. You come to realize he's actually your best searching drone, because of the speed that he's given and the radius that he has for searching for flags.
Yeah, when you watch the video, it's interesting to see that your approach to decompose into multiple levels, you probably address the obstacles as a particular challenge, right? Compared to capturing the flag and getting back. So as you see, some of the other teams seems to struggle at some of the phases of that mission. So how did you decompose like the obstacle problem into something that was easy for you to overcome?
So a few things worked in our favor. One is that you come to realize, based on the scenario of the game, the obstacles are only generated in the center of this field of this map. So you can play the meta game a little bit. You can kind of see the rules of the game and know that there's no obstacles ever in your own territory or in the adversary's territory, meaning you only have to worry about the obstacles for a certain distance on the map. So when you're going through that, another thing you use to your advantage is this simulation does not include flight dynamics, so there's no concept of crashing or moving too fast or momentum. You have to, bleed off. So you can go full speed directly towards a building, and worst case, even if you hit the building, nothing happens to your drone. So you can just then make the decision to turn right or turn left and navigate around it. We did one better than that. They do have a sensor ability to detect the building, but we detected, one unit out in front of the drone, which in the real world would be impossible. You have so much momentum and so much pilot term, you'd have so much smash behind you. You'd end up hitting that building and you wouldn't be able to navigate around it. But in the simulation, you can, you can take that to your advantage, and you can get right up to within 1 unit of that building, see it's there, make a right or a left, keep it very simple, make 90-degree turns, and navigate around it. And then to optimize it somewhat, he memorizes where those buildings that he found are. He can share that information to the other drones, and now they all have a mental map of where the buildings are, and they can make that real quick decision of whether right or left is more efficient.
Throughout the competition, you had some feedback. How would you use that feedback, and were there any major takeaways throughout this challenge?
In terms of the team, the major feedback and the major takeaways was to, match your software development to the problem at hand. And if a simple solution gets you a repeatable, useful end state, then keep it simple, keep it repeatable, keep it something where the human can look at it and debug it. And I think that this reinforced that, where just because new technology might be cool and sound hip to throw AI and throw some machine learning at a problem, not all problems require that level of depth. And then my feedback would be maybe not so much for the team, but more for the ecosystem as a whole. The people putting on the program, on the competition. The feedback is to keep iterating on the competition, to keep making it more challenging, kind of more interesting, more difficult, simpler tools, but more difficult problem, if you can phrase it that way. And you'll find the sweet spot where you're going to get a lot of smart people interested in contributing. But yeah, keeping it a competition is great. I think the competition and crowdsourcing to try to come up with solutions to problems is a powerful tool. And having a lot of people with an incentive, this is something that me and my partner just do in our free time. Like it's fun. Just coding is a fun thing to do. So we're not getting paid to do it. We're not. It's not our job. It's fun to solve problems, and it's an extra incentive to have a competition against other people across the planet. So I would say keeping the competition is great, and trying to do it every year is just going to make it better.